This is the last day of notes for Chapter 7. We're just doing the first 3 sections. And we are proving triangles similar. And these things here, some of them should be familiar because we proved triangles congruent. And when we proved triangles congruent, we had SSS, SAS, ASA, AAS. Yes, all those ways we could prove. So proving triangles similar, there are 3 ways: AA, SAS, and SSS. So first of all, we said if if polygons are similar, then all their angles are congruent. Well, when it comes to triangles, we just need 2 congruent angles, because if two sets of angles are congruent, the thirds would have to be congruent because the sum of the angles in a triangle is always 180. So we just simplify things and just saying we just need 2. So if you can show that 2 pairs of angles, 2 pairs of corresponding angles are congruent, then the triangles would have to be similar by AA similarity. So notice it is AA similarity, not just AA, right? So problems might look like these. Are the 2 triangles similar? Well, just like with congruent triangles, if we have a vertical angle situation, we can count that. So this would be yes, AA similarity. And marking those vertical angles shows me that, this shows me that there's 2 sets of angles. Here, this one, if we wanted to find this third angle, we would do 90 plus 51 plus x equals 180. Or in other words, 141 plus x equals 180. And subtracting 141 from both sides, we get x equals 39. So in other words, this is 39 degrees, which means now we have one set of congruent angles and another set. So this would be yes. And again, AA similarity. Finally, this one. Okay, so it's not the same angles, right? So if this was 68 as well, because if the sides are congruent, then the angles are congruent, we could do and call this x. We know that x plus 68 plus 68 equals 180, or x plus 136, oops, that should be plus 136 equals 180, minus 136, minus 136, x equals 44. Okay, so we figured it out. And the answer is no, right? Because we got 44 degrees for this, and this is 62. So we would just say no. That's it. And we've got work there to back it up. Now, just like with proving triangles congruent, we have the SAS. So just like that, it's like side, included angle, side. Right? They've got to all be in a row together. And side included, angle, side. But remember, the angles are congruent. So angles are congruent, but the sides have to be in proportion. So we got to show that. If we can show those 2 pairs of sides are in proportion, and the angles are congruent, then the triangles would be similar. Or the final way is side, side, side similarity. And side, side, side similarity means basically got to show this, right? That all 3 sides in proportion. Or in other words, they have the same ratio. So let's look here. This one is a tricky one. This is the one where, maybe you want to draw them separately. So there's one. which is KLP. And then we've got the other one, which is KMN. And so numbers we can write in are, we know this is 8, this is 12, and then we know this side is 8 plus 2 or 10, and this side is 12 plus 3 or 15. And so let's see. And then obviously this angle K is the same for both, right? This is the same. So let's see. Does 8 over 10, that is equal to 0.8 if we divide it. And then 12 over 15, let's see. 12 over 15, 12 divided by 15. Is also 0.8. So this would be yes by side, angle, side, similarity. So those two sides are in proportion with the angle in between. And then for this one, let's see, smallest side, medium side, longest side. So let's see, 6 over 9 is equal to 2/3, or 0.6 repeating. The next one, 8 over 12, divided top and bottom by 4 is 2/3, or 0.6 repeating. And finally, 10 over 15, dividing top and bottom by 5, 2/3, which is 0.6 repeating. So this is yes by side, similarity, because we showed all three sides were in proportion. All right, finally, the triangles are similar. They give us a similarity statement like this, and we need to match it up. So let's see. LM goes with VU. So LM goes with VU. And then NM goes with TU. Okay, so if we do purple over yellow, it would be 2x minus 16 over 36. Actually, we know the triangles are similar. We're solving for x. So this is how we're going to set it up. Equals 10 over 30. So this is like what we did in the first section, and we're going to solve it. So let's see. We get 30 times 2x minus 16 is equal to 360. 36 times 10. So 60x minus, let's see, what's 30 times 16? Minus 480 is equal to 360. I'm going to add 480 to both sides. So 60x equals 840 divided by 60. X equals 14. All right, and then same thing over here. Let's see, LJ goes with JT. LJ and JT, and then this goes with this. So if we do big over small, doesn't matter, but so 81 over 9 is equal to 6x plus 6 over 10. So 9 times 6x plus 6 is equal to 810. Distribute. 54x plus 54 equals 810 minus 54. 54x equals 756. Divide. Oops, same answer, x equals 14. And there we go. So you can see how we have similar, if we have similar triangles, you can set up proportions to solve for sides. And then otherwise, the 3 ways to prove triangles similar, 3 ways to prove, but we're not doing proofs. A similarity, SAS similarity, and SSS similarity.